Right now, as you're watching this, the average temperature on Earth is about 15 degrees Celsius. That's the number that keeps oceans liquid, keeps ice caps frozen, and keeps you alive. Now imagine that number climbing. Not to 20, not to 30, all the way to 100 degrees Celsius, the boiling point of water. That's not a heat wave. That's not climate change as we know it. That is a different planet wearing Earth's face. So what would actually happen? Would anything survive? And how long would it take before the world you know completely disappears? Let's find out, because the answer is stranger and faster than you think.
Let's say, hypothetically, Earth's average surface temperature jumps to 100 degrees Celsius almost overnight. What happens in hour 1? The air itself becomes a weapon. At 100 degrees Celsius, the atmosphere near the surface starts behaving less like the air you breathe and more like the inside of an oven set to self-clean. Every unprotected living thing on land, humans, animals, insects, begins suffering fatal heat stroke within minutes. The human body starts breaking down internally at temperatures far lower than this. At 100 degrees Celsius, there is no surviving outdoors. Not for seconds longer than it takes to find shelter that doesn't exist. But here's where it gets stranger. Water doesn't just get hot, it starts to boil. Puddles, rivers, shallow lakes, the surface layers of the ocean, all of it begins turning into steam. And that steam doesn't just float away harmlessly. It thickens the atmosphere, trapping even more heat, creating a feedback loop scientists call a runaway greenhouse effect. The same mechanism, many researchers believe, that turned Venus into the hellish, cloud-choked furnace it is today. Within hours, coastal cities wouldn't just be hot, they'd be shrouded in scalding fog.
The ocean covers 71% of our planet, and it's usually Earth's greatest defender against extreme heat. Water absorbs and stores heat incredibly well. It's the reason coastal areas stay milder than deserts. But at 100 degrees Celsius, the ocean stops being a defender. It becomes a victim. Surface waters begin to boil away. Massive columns of steam rise off the Pacific, the Atlantic, the Indian Ocean, like the whole planet is one enormous pot left on the stove too long. As the surface evaporates, salt concentrations in what's left behind spike to lethal levels for marine life. Coral reefs, already fragile at just 1 or 2 degrees above normal, would be obliterated in days, not decades. Fish populations would collapse as oxygen-poor, superheated water spreads through the upper ocean layers. Even the deep sea, usually insulated from surface chaos, would eventually feel the heat rippling downward. Marine biologists studying much smaller ocean temperature spikes, like heat waves off Australia and California, have already recorded mass die-offs from just a few degrees of warming. Now multiply that stress by a factor of 10. The ocean, the birthplace of life on Earth, would become one of the most hostile environments on the planet. And if the ocean is dying, what happens?
Here's something most people don't realize. Much of Earth's oxygen doesn't come from rainforests. It comes from the ocean, specifically from phytoplankton, microscopic organisms that produce an estimated 50 to 80% of the oxygen in our atmosphere. At 100 degrees Celsius, phytoplankton populations would crash almost immediately. That means the planet's single largest oxygen factory would begin shutting down at the exact moment life needs oxygen most. Meanwhile, the atmosphere is filling with something else: water vapor, at levels never experienced in human history. Water vapor is itself a powerful greenhouse gas, which means the more the oceans boil, the more heat gets trapped, which boils more ocean, which traps more heat. It's a spiral with no natural break. Scientists refer to this tipping point as a moist greenhouse, or in its most extreme form, a runaway greenhouse effect. Once it starts, it's incredibly difficult, maybe impossible to reverse using natural processes alone. At this stage, we're not just talking about a planet that's uncomfortable. We're talking about a planet actively becoming uninhabitable, hour by hour. But surely, somewhere, something survives, right?
This is where the story gets genuinely fascinating. Most complex life would be wiped out within days. Mammals, birds, reptiles, amphibians, all far too sensitive to survive sustained 100°C conditions. Forests would combust or wither. Insects, surprisingly resilient in many disaster scenarios, would still be overwhelmed by heat this extreme. But deep underground and deep in the ocean, a different story unfolds. Extremophiles, organisms specifically built for hellish conditions, might actually thrive. Certain bacteria and archaea already live happily near deep-sea hydrothermal vents at temperatures well above 100°C, protected by immense water pressure that raises the boiling point. Some microorganisms found in hot springs from Yellowstone to New Zealand are known to survive extreme heat that would kill nearly anything else instantly. Tardigrades, those famously indestructible microanimals, could potentially enter a survival state and endure short bursts of extreme heat, though sustained 100°C conditions for weeks or months would push even them to their limits. So if humanity ever needed a symbol of hope in this scenario, it wouldn't be a person, or a polar bear, or a redwood tree. Here's the question that matters most. Is this permanent? The honest scientific answer is, it depends entirely on how the heat got there in the first place and how long it stays there. If this were a temporary spike caused by, say, a catastrophic volcanic event or an asteroid impact vaporizing surface water, Earth might, emphasis on might, eventually begin cooling once the initial trigger fades, if enough of the atmosphere's heat-trapping vapor eventually rains back out or escapes to space. But if this heat is the result of a true runaway greenhouse effect, the same process scientists believe happened on Venus billions of years ago, there may be no coming back. Venus, remember, is thought to have once had oceans, similar in some estimates to early Earth. Today, its surface sits at roughly 465°C, hot enough to melt lead, trapped under a suffocating blanket of carbon dioxide. Earth at 100°C wouldn't be Venus overnight, but it would be standing at the edge of the same terrifying cliff. And the geological history of our neighboring planet gives us a sobering preview of where that road can lead if the feedback loop isn't broken. Now here's the part that should genuinely give you chills. Earth doesn't need to hit 100°C for civilization to face catastrophe. Scientists studying our current climate trajectory have warned that even a rise of just 2 to 4°C above pre-industrial levels, not 100, just a handful of degrees, could trigger mass coral extinction, unprecedented heat waves, sea level rise that redraws coastlines, and food and water crises for billions of people. This video imagined an extreme, hypothetical planet to make a point vivid and visual. But the underlying mechanisms, greenhouse gases trapping heat, oceans absorbing and releasing that heat, feedback loops accelerating change, those aren't hypothetical at all. They're actively measured, tracked, and studied by climate scientists around the world right now. The 100-degree Earth is fiction. The feedback loops that could push us towards serious trouble are not.
So, knowing all of this, would anything on Earth truly be safe if the heat kept climbing? Or is life more fragile than we like to admit? Let me know your thoughts in the comments below. And if this made you see our planet a little differently, hit subscribe, because next time we're exploring another what if that might just change how you look at the world.